Hello students, Easter and after the election process, once again we are beginning our discussion on software engineering topic. We had discussed different software process model like waterfall model, V model, increment process model and RAD model. In this class, we are going to learn another interesting process model called evolutionary process model. In evolutionary process models, software evolves over a period of time. Business and product requirements often change as development proceeds, making a straight line path to an end product unrealistic. Software engineering needs a process model that has been explicitly designed to accommodate a product that evolves over time. Evolutionary process models are iterative. They produce increasingly more complete versions of the software with each iteration. They are characterized in a manner that enables you to develop increasingly more complete versions of the software. There are several types of evolutionary process models. The two popular evolutionary process models are prototyping model and spiral model. Let us discuss each of these models in details in this class. First, let us discuss prototyping model. A prototyping is an initial version of a software system that is used to demonstrate concepts, try out design options, and find out more about the problem and its possible solutions. Prototyping is a best approach when the developer may be unsure of the efficiency of an algorithm or adaptability of an operating system or the form that human or machine interaction should take. In these and many other situations, a prototyping paradigm may offer the best approach. This approach is more effective when the objectives defined by the customer are general but does not have details like input, processing, or output of the requirements. Rapid iterative development of the prototype is essential so that costs are controlled and system stakeholders can experiment with the prototype early in the software process. Prototyping model can be used as a stand-alone process model. Prototyping model assists software engineer and customer to better understand what is to be built when requirements are fuzzy. System prototypes allow users to see how well the system supports their work. They may get new ideas for requirements and find areas of strength and weakness in the software. They may then propose new system requirements. Furthermore, as the prototype is developed, it may reveal errors and omissions in the requirements that have been proposed. A function described in a specification may seem useful and well defined. Prototyping starts with communication between customer and software engineer to define overall objective, identify requirements, and make a boundary. Software engineer listen to the customer carefully And finally, software engineer tried to establish prototype objectives. Then, after establishing the prototype objective, a prototyping plan is proposed. This plan is quickly designed and modeling software layout visible to the customer and end user is developed. Then in the next stage, the quick planning and modeling leads a quick design leads to prototype construction. This prototype is deployed and evaluated by the customer or user. Feedback from customer or end user will refine requirements, and that is how iteration occurs during prototype to satisfy the needs of the customer. Prototype can be served as the first system. Both customers and developers like the prototyping paradigm, as users get a feel for the actual system and developers get to build software immediately. So this figure represents evaluationary process models. Here, listening to the customer is the activity required during the communication. Then quick plan and quick design, that is building or revising the mock-up, is the activity performed for quick plan and quick design. Then the evaluation of the prototype is performed through customer test drives and mock-up, that is prototype construction and delivery feedback activities. The different processes of prototype development includes establishing prototype objectives, defining prototype functionality, develop prototype, and evaluation of the prototype. There is a byproduct after each of these process. After establishing prototype objective, prototype plan is gained as the byproduct. After defining prototype functionality, we get an outline definition for the prototype functionality. After developing prototype, an executable prototype is received as the byproduct. Then evaluation of the prototype means we are generating evaluation report of the prototype. The real purpose of prototyping paradigm is to assist software engineering and customer to better understand what is to be built when requirements are fuzzy. But sometimes the prototyping can be a problematic. The customer sees what appears to be a working version of the software, unaware that the prototype is held together with chewing gum, quality, long-term maintainability. When informed that the product is prototype, the customer cries foul and demands that few fixes be applied to make it a working product. Too often, software development management relents. The developer makes implementation compromises in order to get a prototype working quickly. An inappropriate operating system or programming language used simply because it is available, and no. After a time, the developer may become comfortable with these choices and forget all the reasons why they were inappropriate. The only solution to this problem is to define the rules of the game at the beginning. The customer and the developer must both agree that prototype is built to serve as a mechanism for defining requirements. We have discussed prototyping evolutionary model. Now we are going to discuss spiral model. Spiral model is an evolutionary software process model that couples the iterative nature of prototyping with the controlled and systematic aspects of the waterfall model. It has two distinguishing features: a cyclic approach for incrementally growing a system's degree of definition and implementation while decreasing its degree of risk. Second feature is that it has a set of anchor point milestones for ensuring stakeholder commitment to feasible and mutually satisfactory solutions. Anchor point milestones is a combination of work products and conditions that are attained along the path of the spiral. The software process is represented as a spiral rather than a sequence of activities with some backtracking from one activity to another. Each loop in the spiral represents a phase of the software process. Thus, the innermost loop might be concerned with system flexibility, the next loop with requirements definition, the next loop with system design, and so on. The spiral model combines change avoidance with change tolerance. It assumes that changes are a result of project risk and include explicit risk management activities to reduce these risks. The different stages of the spiral model or different phases of the spiral model consist of customer communication, planning, risk analysis, engineering, construction, or customer evaluation. Or we can say each phase consists of customer communication, planning, modeling, construction, and deployment. Communication includes the customer communication. Planning includes the estimation of the work, scheduling of the work, and risk analysis of the each target. The modeling activity includes the analysis and design of the project. Engineering aspect is determined at this stage. Then construction phase happens. The coding activity and testing activity is performed during this phase. And then deployment, that is the delivery and feedback mechanism, is taken as the last stage in this spiral model with each iteration stage. In 1980s, Boehm introduced this process model known as spiral model. There are several advantages for this spiral model. Spiral model avoids the problems resulting in risk-driven approach in the software development. Second advantage is that spiral model specifies a mechanism for software quality assurance. There are some set of activities for software quality assurance activities in spiral model. Third advantage of spiral model is that re-evaluation after each step allows changes in user perspective, technology advances, or financial perspectives. However, there are some disadvantages with spiral model. Assessment of project risk and its resolution is not an easy task. If a major risk is not uncovered and managed, problems will undoubtedly occur. The main difference between spiral model and other software process models is its explicit recognition of risk. Another problem area of spiral model is that spiral model may be difficult to convince customers, particularly in contract situations, that evolutionary approach is controllable.